So your learning target for this lesson is to be able to divide by whole numbers and get decimal quotients, and divide by decimals and get decimal quotients. So we're going to be reviewing division by whole numbers and decimals, and the dividend and divisors, the two numbers that you're given, are both positive. And that way you are going to be able to divide in your C4U, divide positive and negative numbers, decimals and whole numbers, to get positive and negative decimal quotients. Okay, we're going to start with 203 divided by 12. They're both whole numbers. So I'm going to set up my division bracket. The dividend, the first number, always goes under the house when you have a division symbol with the dots. So I'm putting 203 under the house. This is the divisor. It goes at the door. Notice you want to leave space between your numbers. You want to write neatly. Some of you may need to turn a notebook paper sideways to create columns, and you put each digit in its own column. If you don't write neatly, that's what you're going to need to do, because if I can't read it and you're on top of things and borrowing and I can't see what you're doing because it's too cramped and not neat, you will have to start it over. So make sure you're setting things up neatly. Now I start with 12. This is the required steps for long division. We're going to start with 12 and we're going to divide it into that first digit of our number 2. How many times can you take 12 away from 2? You can't. You only have 2. You can't take 12 away from it. Okay? You don't have enough. So then we go out to the second digit. Whenever you put a 0 on the house, you just go out to the next digit and you create the number 20. How many times does 12 go into 20? The answer is 1. Now we're going to take 12 times 1 and we're going to subtract it. When you put the 1 on the house, that means you can take 12 away from 20 one whole time. You don't have enough to take it twice. So we can get as close to 20 as we can without going over. All right, so we're going to subtract, and we get 20 take away 12 is 8. If you want to, you can show the borrowing there. And then we're going to bring down the next digit in line, which is a 3. We're going to ask ourselves, how many times can we take 12 away from 83? We're going to divide again. How many times does 12 go into 83? Well, it goes in 6 times. 12 times 6 is 72. 12 times 7 is 84. 84 goes over. It's too big. We only have 83. We can't take 84 away. But we can take 72 away. That's taking 12 away 6 times. And I get 11 as my remainder. And so we used to have, when you first learn long division, you would say R11. But we're not doing that in this lesson. We're writing decimal quotients. So we're not going to stop. We're going to keep dividing. So in order to keep dividing, we first need to put a decimal in place. This number is 203. The decimal goes right there in 203. So we're going to stick it in right there. And then we're going to put it up on the house, straight up. Now we ignore the decimal. We pretend it's not in the problem anymore because it's right where it needs to be in our answer. Our answer is 16 point something. Got to figure out what the point something is now. Once I put that decimal in place, so I still have 203, I'm going to add a 0 to the end of the number. It makes the number longer, but does not change its value, so it's legal to put it in there. Now we need to figure out how many times 12 goes into 110. Well, I know 12 times 8 is 96, and 12 times 9 is 108. 12 times 10 is 120. Okay, 9 is the answer. 108. That's as close as we can get to 110 using 12 to multiply by. And when I subtract that, I get 2. And I have a remainder. I got to keep going. I'm going to add another 0. Again, it just makes my number longer, but it's still 203. It just looks different because I added that 0. And I'm going to divide 12 into 20. How many times can I take 12 from 20? And the answer is once. And when I subtract, I get 8. I have a remainder. I got to keep going. I'm going to keep going till my number ends or repeats a pattern. And I'm going to do how many times does 12, and I need to move this line out of the way that I have here. Scoot that over. How many times does 12 go into 80? How many times can I take 12 from 80? And the answer is 6, and I get 72. and I subtract. When I subtract, I get 8 again. So I'm like, ugh, I have a remainder. I got to divide again. So I put a 0 on the end, and I bring it down, and I have to divide 12 into 80 again, and the answer is going to stay the same. It goes 6, which is 72. I'm in a loop. At this point, my number is repeating up here. Every time I divide again, I'm going to end up with an 8 for my remainder, add a 0, 80, and then a 72 again. So we say this is a repeating decimal. So we just put a repeating bar over our answer. So our answer is 16.916 repeating. Okay, so that is our final. So when you're dividing and you get a remainder and you've run out of digits, you put the decimal point in. At the end of your number, put the decimal point on the house. Now forget about the decimal and just add zeros till your number ends or repeats a pattern. So this was a repeating decimal quotient. All right, our next one is 15 divided by 60. Now when you see this, a lot of students have trouble with this one because they always want to put the bigger number in the house, and that's not how it works. This is a fraction. This is a proper fraction, which means the top number is smaller than the bottom number, which means when we divide this, because remember, it also means this, 15 divided by 60, if I use that other symbol for division. The fraction bar is division, right? So 15 divided by 60 is going to be a number that is smaller than 1. So we're going to set this up. We're going to put the 15 in the house. This is your total. And you're splitting 15 into 60 pieces, 60 equal sized pieces. So we're going to put 60 at the door. It's like saying you have $15 and you're splitting it with 60 people. How much does each person get? Not a lot, right? Okay, so I have my $15 in the house and I'm going to start dividing. How many times can I take 60? We're going to start with this digit. Every digit under the house gets a digit above it. So how many times does 60 go into 1? It doesn't. 1 is too small. You can't fit 60 into 1. In other words, you can't take 60 from 1. How about how many times can you take 60 from 15? You still can't. 15 is smaller than 60. All right, so now we're out of digits and I still have 15 here. So I'm going to put a decimal in. I'm going to put the decimal on the house just at the end of the number so I can keep dividing, so I can get a decimal quotient. So I'm going to put a 0 here. How many times does 60 go into 150? Well, if you're not sure, you can guess off to the side and start multiplying. My guess is that 60 can go into 150 2 times because I know 60 times 2 is 120. If I go up to 3, it's 180. It's too big. So I'm going to go 2 times. My 2 goes above the 0. And I go 60 goes into 120 twice, or 150 twice. 60 times 2 is 120. Now I subtract. And I get 30. I have a remainder, so I have to keep going till my number ends or repeats, which means I got to add another 0. And I'm going to bring that 0 down. How many times does 60 go into 300? Well, I know 6 times 5 is 30. So 60 times 5 is 300. If you don't know that, you just go off to the side, start guessing numbers until you get as close to 300 as you can without going over. So I'm going to put a 5 up here. And 60 times 5, again, is exactly 300. So I'm going to subtract 300, and I might have no remainder. My number ends. So I am done. My answer is 0.25, which is 25 cents. So if I have 15 people and $60, each person gets 25 cents. That hopefully will help you understand why the answer is the way it is. When you have a proper fraction, that means the numerator is smaller than the denominator. You will get zeros here before your decimal point, and it'll be a number less than 1. All right, so that's an example of a number that ends. It doesn't repeat a pattern. It comes to an end with no remainder. This one, you're going to always have a remainder. It's just going to repeat that pattern. So those are 2 examples of dividing whole numbers and coming out with a decimal quotient. In this next example, we're going to divide a decimal by a whole number. And and see how we have to set that up using this long division steps. So you're going to want to start with your bracket, and the 2.962 goes in the house. Again, neatly leave space between your digits so that you have room to borrow and subtract, because that's going to happen, and an 8 at the door. Okay, now when we have a whole number right here, we are ready to go, except we just have to put this decimal straight up on the house, right between the 2 and the 9. And once we've done that, we can ignore that decimal point in our problem, because it's right where it needs to be for our answer. So we can pretend it's not underneath that house anymore. So every digit under the house needs to have a digit above it, and that digit will be between 0 and 9. Okay, so we're going to start with 8 goes into 2 0 times. Okay, when we put a 0 on the house, we can just extend out to the next digit. 8 goes into 29 3 times. 8 times 3 is 24. Now I'm going to subtract that. I'm going to take 8 away from 29 3 times for a total of 24. I'm taking 24 away and I get 5. And I'm going to bring down that 6. How many times can I take 8 away from 56? Well, the answer is 7. I'm going to put that right above the 6 that I brought down. 8 times 7 is 56. 56 take away 56 is 0. I'm not done. I've got a digit left. I have to bring it down. I'm going to put a 2 here. How many times can I take 8 away from 2? I can't. So I'm going to put a 0 here. And I have a 2 still remaining, so I'm going to put a 0 here, and I have to keep going till my number ends or repeats, and I get a 0 here. For 20, I made 20. How many times does 8 go into 20? The answer is twice. That's 16. And I subtract. Darn, I have another remainder. I got to keep going. I have a remainder of 4. 20 take away 16 is 4. So I'm going to extend my little long division. I'm going to put another 0 on the end, and I'm going to bring it down. How many times does 8 go into 40? Oh, thank goodness. It goes in 5 times exactly. 8 times 5 is 40. And I am done. My number ends. The answer is 0.37025. That number is less than 1, which makes sense. I'm dividing. It's 3, if I round it, 3 divided by 8. That's the fraction 3/8, if I'm just estimating. So it's going to be a number less than 1. It's going to be a number less than 0.5. It's 0.37025. That's your final answer. All right, so in this next example, we have a fraction, and it is an improper fraction. The top number is bigger than the bottom number. It's 5.13 divided by 1.8. So I'm expecting to get an answer that's bigger than 1. So I need to set up my division problem. And what you'll notice on this problem that is a little different than our last problem is we're not dividing by a whole number in this problem. We're dividing by a decimal. Here, let me get that blue on. That's kind of confusing. So to set it up, again, your numerator always goes in the house. Whether it's bigger or smaller than your denominator, it doesn't matter. And when you set it up, make sure you give yourself some room to do your division. And we're going to answer our quotient as a decimal. And so we're going to divide till this number ends or repeats a pattern. The number I'm dividing by is 1.8. It's a decimal. And we do not like dividing with the bracket and having a decimal at the door. This right here, we do not like that. So the rule of thumb to do these problems, the first thing you need to do is to clear that decimal. In other words, move it over till you get a whole number. So I've got 18. When I move it and I put it over here, I've created the whole number 18. Now, if you do that to this number to clear it, you have to match it with the number under the house. You also have to clear that by moving it over one place. So I want to explain how that works real quick below, and don't write this down, just watch. So our original problem was 5.13 divided by 1.8. And I just moved the decimal point in the top and the bottom numbers one place to the right. When I do that, I basically multiplied each of those numbers by 10. 5.13 times 10 is 51.3. 1.8 times 10 is 18. So I've just created a new division problem, or a new fraction. And although these two fractions look different, they are equivalent. When you divide this, you'll get an answer. And when you divide this, you will get the exact same answer. These are equivalent fractions because I multiplied the top and the bottom both by the same amount, 10, which moved those decimal points one place to the right. So even though my problem now looks different, because it's now 51.3 divided by 18, the quotient will be the same. So I've swooped the decimal, I've swooped a match, and now I come up on the house and I put my decimal in my new spot. It goes right there. It doesn't go right here. It goes over here. Now I'm ready to divide. I ignore the decimals completely. It's as if I'm dividing 513 by 18. 18 goes into 5 0 times. 18 goes into 51 2 times. 18 times 2 is 36. I subtract it. Again, I'm trying to get as close to 51 as I can without going over. That's 2 18s. Okay, got to borrow. 11 take away 6 is 5. 4 take away 3 is 1. Bring down the 3. How many times does 18 go into 153? Well, if you don't know, you better start guessing. Do some multiplication off to the side. I'm going to guess that 18 goes into 153. I'm going to guess 7 times. Just a guess. 8 times 7 is 56. Carry the 5. 7 times 1 is 7. Times plus the 5 is 12. That's 126. I don't think I'm close enough. I got under 153, but I think I can get closer. So I'm going to go 8. 8 times 8 is 64. Carry the 6. 8 times 1 is 8 plus 4, or plus 6 is 14. Oh, there it is. So I can get closer if I multiply 18 by 8 without going over. But that's as close as I can get, 144. So I put my 8 on the house, my 144 underneath, borrow and subtract. And I have a remainder of 9. I'm not done. I got to keep going. So I'm going to add a 0 to the number and bring it down. How many times does 18 go into 90? Well, looking at my guesses, 7 is too much. It's 126, 7 times. So I'm going to guess under 7. I'm going to guess 5. 5 seems like a solid number to try. So I'm going to just get rid of some of that work. 8 times 5 is 40. Carry the 4. 5 times 1 plus 4 is 90. Oh, it's 5 exactly. I have no remainder. Now I can stop dividing. So my answer to 5.13 divided by 1.8 is 2.85, which makes sense because if I do round this to 5 and round this to 2, 5 divided by 2 is 2.5. So I'm got it pretty close to that estimate. 2.85 is my quotient. So when you divide by a decimal, the number at the door is a decimal point, you need to create a whole number by swooping the decimal as many places as it takes to get it to a whole number. So if I swooped it once, I have to swoop this once underneath. If I needed to swoop it twice, I would need to swoop this one twice underneath. So you got to match. Once you have it, the decimals moved, you take your new location under the house, you put it up top on the house. Now you pretend there's no decimals. You do your long division steps as they're shown here. Every number on the house gets a digit above it. And when you're done, you know you're done when you get no remainder or a repeating pattern, then you're set. That's it. Long division, dividing by a decimal. So you should be good to go. You just need to incorporate those integer rules when you're dividing, and you should be all set. Good luck.